That's humidity ratio, where's relative percentage? Oh, there you go, relative humidity. So say, for example, if it was 20 degrees and 25 relative humidity, you just, 25 is right in between 20 and 30, right? Right, this way. So you just follow right about there. And then from here, you can get all your pieces of data. You know, if you look straight over, you can find how much water content there is. That's the actual humidity. If you go, I think where's an enthalpy right there. So if you were at here and you need to find the enthalpy, you just go up this way and you'll have 28 something kilojoules per kilogram of dry air. Yeah. So you can get all the information from that just from those 2 points. Okay. So each thing will be recording preheat, post heat. For each situation, you need to interpret this correctly. So he's going to be sending you an Excel data that has a bunch of stuff on it. So I'll tell you how to filter through it. Let's see. Anything with the subscript 1 is right there. Okay, subscript 2 is over there. So just the same setup that he showed you in class. But the hard part to see is, once this is all running, it's all one big piece of Excel data. So what you need to do, let's go over here and see what's actually on. There's no boiler. This is preheat right there, post heat, and AC compressor. So you can see this first case, the first 3, there's nothing running at all. Okay. Now, if I ask you, how do we get this first case, simple heating with cold air coming through? So you got to think about each of those 3 things. So it's going to tell you straight up, simple heating, cold air. If I want cold air to come through, that's off. The AC compressor is on, because that's sending cold air in, and we're going to be heating it. So we want cold air to come in, we want to heat it. So compressor's on, post heat is on. So you're going to look through here to where you see AC enabled and post heat enabled. It's a huge Excel file. You just keep scrolling down until you end up finding. So there's enabled. Where's the spot? There's both. Keep going somewhere, hopefully. Disabled. Come on. That's a horrible example. But he's gonna send you one that will work. He's gonna filter through all of it. So that's for that case that you would do. There's multiple data points. So what you would want to do is find out the first time that both of these got enabled, and maybe go to near the end of that data set and look over, because that's when it's the most steady state. And so what you do, if these were, say, both enabled, we found out that was the first case for simple heating. You would go over here. You don't need to worry about the time. Just go to the last time that it's most steady. And you have everything you need right here. Duct temperature 1, 2, 3. And let's see, relative humidity 1, 2, 3, 4. Right, but we really wouldn't need one, or we would just need 2. Let's see. No, you just need 3 and 4.
Okay.
3 is the cold air coming in, and 4 is it being heated. Can you understand that?
Yeah.
So that's all you need. You need duct temp 3 and 4, relative humidity 3 and 4. Once it's most stabilized, you would plot your 0.3 somewhere here, 0.4 somewhere here, and that once you have those 2 points, you just look over here, and that's your enthalpy change, right? Okay. And to figure out that, if you did like a energy balance on that, you have H1, m dot H1 coming in minus m dot H2 going out equals Q in, I guess this is for heating.
Yeah.
All right, and that's it. And that's it for every single case. You just have to realize what this one is. So what would this situation be? We want to heat room temperature. So that would be off. That would be off, and it's just going to suck in room temperature, and we're going to be heating it. So again, you'd only need points 3 and 4 for that. Cooling with humidification, so we want to cool room temperature. So off, on, and off.
Yep.
Room temperature is coming in, and we're going to cool it. So you'd only need data points 2 and 3.
Okay.
And then you can find that, boom, get it right there. So you're going to want to print multiple copies of this out and jot them down to find out actually what each Q dot is.
When you say which one you say this one is going to be on?
Cooling with humidification for room temperature. Yeah, so this would be on. The only thing that would be on would be the coil.
So we're sucking in room temperature air, and we're only cooling it.
Yeah.
We're not modifying it in any way.
If you don't want to jot down each one, if you just wrote down what he had in class, 1 to 2, and 3 and 4, and figure out these cases, you can actually just think about what it is. It's not too bad. For example, you want to cool
So write this stuff down. It'll make more sense to you.
Yeah, I don't know if you got that in class. If you want to cool hot air, you're gonna have the preheater on. That's fix hot air coming in, and the compressor will be on. Post heat would be off. That kind of makes sense?
Yeah.
All right. If he's got it, that's good. This one.
We're basically just we're turning. Basically, whatever we turn on and off is how we're controlling.
Yes.
What's coming in, basically.
Yes, and that's what you can look for.
Yeah.
What is ever enabled, disabled, enabled, and look for where it's steady at the very end of that data set.
Okay.
As far as evaporative cooling goes, let's see. So he's gonna have to run. You need to look for the either he's gonna tell you, or look for the section where that is on for a long period of time.
The last one?
No, the compressor. Really cold. Bunch of ice builds up on it. Then shuts all three of them off.
Okay.
Fan's still going, and that's the point where that starts to melt, and this is going to pick up moisture as it goes through. And so near the end of that data set is the one you can actually get. You can find this.
And that's when. At that point, it'll be only that will be enabled, and then all of a sudden that will get disabled too.
It'll get only that will be enabled, and then boom, nothing.
And that's where.
The data.
And he has to send us that.
Yeah, it'll be in here too. He needs to either tell you or he can look for it. That's gonna be between points 2 and 3.
Yeah.
And you can find M.W.
And that's for evaporative cooling.
Yes, you can find M.W. by looking at the points 2 and 3, finding the relative humidity change. You know, for each of these cases, if you look in your thermal book, single bowls, whatever he has you guys, that has a good explanation of every single one and what it should look like on the site chart.
Okay.
Look like, not exactly, this is the real world stuff. But what it should look like, if you follow those steps and what they do on the site chart, this will be really easy. As long as you can filter through this fine, it's not that bad. I think that's it. Let's see, so all you really need here is the duct temperatures, relative humidity 1, 2, 3, and 4. You don't need to worry about this low side, high side, or any of this junk. You're not worried about pressure, and you only really need to worry about what's enabled or disabled for what we have, which are preheat, post-heat, compressor. Okay, we don't have a boiler or any of that stuff here, so don't worry about that. You just need these three, and temperatures, and humidities.
Cool.
That's it.
That's done?
That's done. And you're the first group.
Ready to go?
We're not actually doing anything. Okay.